Hi friends, good morning. Please look at the next problem. Friends, this is problem number 22 of exercise 15.1 of chapter probability. Friends, two dice, one blue and one grey are thrown at the same time. Complete the following table. Here one table is given and sum of the numbers on the two dice, is given and their probabilities we have to calculate and complete the table. See friends, sum 2 it is already given and sum 8 it is already given and we have to fill up the next column. Okay friends, see sum 3, how many outcomes are favorable to get the sum on the two dice. See, total number of cases if two dice are thrown, you know the total number of cases, that is 6 into 6, 36. So for all the events, total number of cases is 6 into 6, 36. So n of s is 36. N of s is equal to 36. Now let us calculate the probability of each event, that is for the event sum 3, probability of sum 3 is equal to, see sum 3 means 1 plus 2 3, 2 plus 1 3. So you see diagonally 1 plus 2 3, 2 plus 1 3. So for getting sum 3, the sum 3 on the two dice, the favorable outcomes are 2. Total number of outcomes 36. 2 by 36, that is equal to 1 by 18. So this probability is 1 by 18. Next, probability of the event to get the sum 4 on the two dice is 1 plus 3, 2 plus 2, 3 plus 1. 1 plus 3, 2 plus 2, 3 plus 1. So three cases are favorable. Three outcomes are favorable for getting the sum 4 on the two dice. So probability of getting the sum 4 is equal to three outcomes are favorable. So 3 by 36, that is equal to 1 by 12. So for getting the sum 12, the probability is 1 by 12. Now let us see the probability for getting the sum 5. See, this is over. 1 plus 4 5, 2 plus 3 5, 3 plus 2 5, 4 plus 1 5. So for getting the sum 5, how many outcomes are favorable? 4 outcomes are favorable. So probability of getting the sum 5, we have 1, 2, 3, 4. 4 outcomes are favorable. 4 by 36, that is equal to 1 by 9 is the required probability. Then the probability of getting the sum 6. See, 1 plus 5 6, 2 plus 4 6, 3 plus 3 6, 4 plus 2 6, 5 plus 1 6. So there are 5 outcomes. Favorable for getting the sum on the two dice 6. So probability of getting the sum 6. Is equal to how many cases? 1, 2, 3, 4, 5 cases are favorable. 5 by 36 is the required probability. So here getting the sum 6, 5 by 36. Now let us calculate the probability for the sum 7. 1 plus 6 7, 2 plus 5 7, 3 plus 4 7, 4 plus 3 7, 5 plus 2 7 and 6 plus 1 7. So how many cases? 1, 2, 3, 4, 5, 6. 6 cases are favorable. 6 outcomes are favorable for getting the sum on the two dice 7. So probability of getting 7. How many outcomes, friends? 6. 1, 2, 3, 4, 5, 6. 6 by 36 that is equal to 1 by 6 is the required probability. 1 by 6 is the required probability. Then probability of getting 8 it is already given. Now let us calculate the probability of getting the sum 9. Probability of 9 here I am doing, friends. Probability of getting 9. Probability of getting 9. See, this is over. This is already given. 8 is given. 8 is given. Now we are calculating 9. 3 plus 6 9. 4 plus 5 9. 5 plus 4 9. 6 plus 3 9. So for getting this sum 9, 4 outcomes are favorable. So favorable outcomes 4. Total outcomes 36. That is equal to 1 by 9 is the required probability. Now getting the sum 10. See, 4 plus 6 10, 5 plus 5 10, 6 plus 4 10. So for getting the sum 10, 3 outcomes are favorable for getting the sum 10. So 3 by 36 that is equal to 1 by 12. Now probability of getting 11. 5 plus 6, 6 plus 5. Two outcomes are favorable, 1 by 18. And for getting the sum 12, only one case, 6 plus 6 12, 1 by 36 is the required probability. So here getting sum 10, 1 by 12 and 1 by 18 and 1 by 36. So now we have completed the whole table. And now one more question is also given, friends. From the above table, a student argues that there are 11 possible outcomes. 11 possible outcomes. Yes, 11 possible outcomes. 9 plus 2, 11. 11 possible outcomes. Therefore, each of them has a probability of 1 by 11. Do you agree with this argument? Friends, no. So, see, these events are not equally likely events. These events have different events have different probabilities. So the events are not equally likely events. So the argument of this student is not correct. Okay, friends. Thank you. Have a nice day.